Can you make it Math Sunday? Math Sunday. Alright guys, welcome. Come on in, join the show. Now we'll equation math for you to solve, so once you have an idea, go ahead and pop it in the chat. We got it. Videos coming up, all sorts of stuff going on. And give everybody a chance to get their answers in. Just a little multi-step equation to get us started tonight. And if you have any concepts or questions or anything that you want me to go over, put them in the chat. Even if you have like a very specific question, anything you need help on your math, let's get into it. Or science. Maybe you have a chemistry file coming up. Go ahead and put it in the chat. And then YouTube has strawberry elephant. Alright, Cody, we got our first answer in. Ooh, got some other answers coming in now. So for those of you who are just joining us, welcome. I'm here for any math or science help that you might need. You know, it's Sunday night. I know most people don't have school tomorrow, but maybe you're getting ready for finals, and there's a lot of finals that are going on this week. So if you have any questions, concerns, anything like that that you want to get into, let's pop it in the chat. We can work it out. Alright, give us just a couple more minutes to work through this equation. If you have any requests or anything like that, let me know. Yeah, yes, we will get into it in just a minute. Ooh, physics. Oh, physics is a little tough. Do you have any specific, like if it's like a math thing? Wait, I got it right. H. Excellent.
And the other state editor, PC. And the other state editor, PC.
That was a break. Interesting. Alright, it seems like maybe over on YouTube we're having a little bit of sound issues, so let me see if we can get that going.
And the other state editor, PC. And the other state editor, PC. And the other state editor, PC.
Alright, so let's go ahead and let's get into this. Let's just kick us off with a multi-step equation right here. So the first thing we're going to do is anytime you want to or you need to solve an equation, you want to simplify both the sides, then start moving things around so you've got all the variables on one side and all the numbers on the other side. Okay, and that's even if you're solving a system of equations where you have more than one variable going on. You just always want to simplify, then solve. So to simplify, we're going to take this negative 5, and we're going to distribute it here. So distributing just means that I've got negative 5 times x, and negative 5 times negative 4. So I didn't do anything to my 28 minus 3x over on this side. So it's going to stay as 28 minus 3x. Negative 5 times x gives me negative 5x. Negative 5 times negative 4 gives me plus 20. So now that I've got everything simplified on either side, I've got us like, I've got everything distributed, I've got all the like terms combined and all of that. And I'm going to solve using those inverse operations. Either way,
I can like subtract 28 or I can subtract 20, as long as I end up with all the variables on one side and all of the numbers on the other. So what I'm going to start doing, I'm going to put all the variables on this side. So that means I need to get rid of the 5x or the negative 5x over here. So I'm going to add 5x here. But what I do to one side, I have to do to the other. So negative 5x plus 5x, that cancels out. Negative 3x plus 5x gives me plus 2x. Now I haven't done anything to the 28, and I haven't done anything to the 20 over here. Okay, so now we've got 28 plus 2x equals 20. Such a late time. It's only 7 o'clock here. I don't know where you are, but it's I mean, 7 o'clock is pretty reasonable time. This is, I like to catch everybody when they're kind of doing their homework, at least in the eastern United States. That's where we are, so that's what we're doing. All right, so now we're going to subtract 28 from both sides. So 28 minus 28. Oh, it's midnight in the UK. Yeah, woof. Oh my goodness. Okay, so 2x equals negative 8. So then what I'm going to do is I'm going to divide both sides by 2, because 2 times x equals negative 8. So I'm going to divide by 2, so then I end up with x equals negative 4. Okay, so x equals negative 4. Okay. We can do finding slope for sure. Yep. All right, so for those of you who are just joining us, welcome. My name is Sarah. I've been a science and math teacher for over 20 years, and I'm here to just answer questions, homework help. Maybe you've got a final or a test coming up this week. If you have any concepts or anything that you just want me to go over, or even a specific question, I'll do what I can to help you out. We mainly focus on between pre-algebra or like middle school math and like algebra 2-ish. Sometimes we can get into pre-calc, but there's a lot of concepts that just don't really work very well in this format. So we try to, there may be some things that I just say, like, I can't really help you out with that, but you can always put a specific question in the chat because we have a really good community here and we'll help you out as much as we can. Okay. Oh, the PERT test. All right, so FR, I think. Somebody was asking, when do you teach science? If you have a specific science question, put it in there. Okay, so can you show how to find the equation of a tangent line from an ordered pair? A tangent line of a circle? Is that what you're asking for, user? The slant asymptotes for hyperbolas, we're not really going to be able to get into that. But Dex, I will get into finding slope right now. All right, so slope is all about change. Okay, so slope is really just about the rate of change. Now, typically when we're talking about slope, we talk about it with so grade 11 in the UK system, or I'm sorry, so an 11th grade student would typically be taking like algebra 2 or like a pre-calculus class. That would be, yeah, but I feel like, I don't remember, do you guys have kindergarten, or is grade 1 like the first year of school, like you're 5 or 6 years old? Because then like grade 11 or year 11 might be our 10th grade. I'm not sure. Okay, so slope, when we're looking at the rate of change, typically when we're talking about slope, we typically start out talking about the rate of change in just a straight line. Okay, so a linear equation or something like that. Okay, so we've got this straight line. So the slope is the rate of change over, slope equals, we say it's rise over run. Okay, so the rise is the vertical change up and down, and the run is side to side. So this is sort of like when you're walking up like the side of a mountain, right? If there is a lot of vertical change and not a lot of horizontal change, that slope of that mountain is going to be very, very, very steep. Okay, but if you're doing more of like there's a lot of horizontal and just a little bit of vertical, a lot of horizontal, a little bit of vertical, that's going to be a much lower slope. Okay, it's going to be a little bit easier to walk up. You can also think of this as like a staircase. And that's usually how I tell my students to think about this. So we find 2 points. I mean, the slope for a linear equation is going to stay the same no matter what. But if we look at the line as a ramp, okay, and we want to break this down into like a stair step. Okay, now we're going to break it down into stairs that are all the same size. Okay. So we're going up the stairs, okay, climbing up the stairs, going up and up and up and up. And we've got that ramp, right? That line that goes up. So here, every time we go forward 2, we go up 3. So forward 2, up 3. Forward 2, up 3. And these stairs are going to stay the same the whole way through. Okay. Oh, you call it gradient in the UK. Oh, interesting. Yeah, so it's slope in the US. We all call it slope, or again, rate of change, right? But the gradient, I like calling it gradient. That's nice. So here, our slope for this line would be, our rise is 3 and our run is 2. So the slope of this line would be 3 over 2. Okay. So that's what slope really is. Now this is a positive slope, okay? But you can also have a negative slope. So you could also have a line that looks something like this. Okay. Now here, between these points, let's see, we're going down 3 and over 5. Okay, so this slope, and we use the letter like a lowercase m is our slope. Okay, in this case, this is what's called a negative slope. because I'm going down 3 and over 5. And it's got it's kind of sort of like downhill. Okay. So negative 3 over 5. That is our slope for this line. Okay. Oh, and Anaya, you do y equals mx plus c. Is c your y-intercept? That's so interesting because we do y equals mx plus b here. So y equals mx plus b, that is the equation for a linear, well, I guess that's the slope-intercept form of an equation. So the y-intercept, so we can figure out the y-intercept for either one of these. Let's do it for this one with the positive slope. Okay, now you guys saw I just made this line up, so I have no idea what this y-intercept is going to be. Okay, but the y-intercept is where this line is going to cross the y-axis. Okay, and that tells us where that line is going. Okay, so let's take a look at this line here. So our slope for this line is 3 over 2. Now I can pick any point that it passes through along this line. So I'm just going to pick this point up here. So I've got 1, 2, 3, 4, 2, 4, 6, 8. So this point right here is negative 4, 8. The way that I know that that's the coordinate point for this is that we did, from the origin, we go to negative 4. So we go 4 spots down the x-axis and then 8 spots up. That's where, so we've got x comma y. So negative 4, positive 8. So our point, so we're going to say x1, y1. That's our coordinate point that it passes through, which is negative 4, 8. So I have the slope and I have a point. Now I have options now, so I can use point slope form or I can use slope intercept form. I'm personally going to use point slope form. Okay, and point slope form is a way of writing a linear equation that we have y minus y1 equals m times x minus x1. Now this x and this y, those are going to stay as x and y because the equation is going through, the equation is going through and it's a way of understanding the relationship between x and y. Okay, so I'm going to plug in what I know and solve for what I don't know. So I know that this y is going to be y, and I know that this x is going to be x. Everything else I'm going to plug in. So my slope is 3 over 2. And then let's see, my x1 is, I'm going to do minus 4. So it's the same thing as doing plus 4. And this is y minus 8. And now to get my equation into slope-intercept form, which is just y equals mx plus b, I'm going to solve it for y. So in order to solve that, I'm going to distribute my 3 over 2. So I've got y minus 8 equals 3 over 2 x plus 6. Oh, that worked out pretty nicely, right? So 3 over 2, so minus negative 4 becomes plus 4. 3 halves times 4 is going to be 6. Okay, because that's 12 over 2, which is 6. And now I'm going to add 8 to both sides. So my equation for this line is y equals 3 over 2x plus 14. So that means that this line right here, has a rate of change or a gradient, right? You go up 3 over 2, up 3 over 2, up 3 over 2, and then it's going to cross the y-axis at 14. So my board doesn't go all the way up to 14, but if it did, you would see that it would cross right about there. And that's about where it goes, right? That's about where it looks. Okay. Yeah, so point slope form can be really, really useful. Yeah, it can be really handy. All right, let's put up another equation. Let's see how you guys do on the solving another equation, okay? But again, if you've got any test questions or homework or anything like that coming up, let me know. Put it in the chat, okay? And we can go through it. Okay, let's do, should we do a quadratic or should we do just solving a linear equation? Oh, Micah, over on YouTube, you're asking for percents. Okay, so percents I know is a big thing. Right now, it primarily lives in the 7th grade curriculum in the U.S. So, all right, so what percent of 130 is 27? So percent literally means like per 100. Okay. So what this is talking about is if you've got two quantities, right? We call them the part and the whole. So the part over the whole, it's sort of like a fraction, sort of. Okay. But the relationship between the part and the whole, you're asking like, well, what is it out of 100? So this would be your percent out of 100. All right, so you've got the part to the whole and the percent to the 100. Okay. Ooh, Strake, we can do Pythagorean theorem. Are you looking for missing side lengths? What are you looking for? And I'll get to that next after we go through percent, okay? So when you're asked a question about percent, you have to think about, okay, do I know the part? Do I know the whole? What am I looking for, right? So that question was, could you do what percent of 130 is 27? Okay, so think about what do I know and what do I need to know? Okay, let's see, I know that of 130, that would mean that my whole is 130. The part is 27. Okay, now the other way you can look at this is like, what do I not know? So that means that I know everything else, right? So in this case, it says like, what percent of 130 is 27? So I don't know my percent. So I'm trying to figure that out. Okay. So when I'm solving now this just becomes a proportion, right? So I'm going to cross multiply and solve for that percent. Okay. So when I cross multiply, when I'm solving a proportion, I'm going to multiply these two. Okay, and I'm going to change this to t. Okay, so t is my percent. Okay, so that's going to be 100. So that's going to be 100 times 27, which is 2,700, equals 130 times t. Okay. I'm going to divide both sides by 130. I get 2,700 divided by 130, which is going to give me my value for t. So that's 20.769 on and on and on is t. I don't know what your teacher's going to ask you to round it to. Usually it's like to the 10th of a percent. So 20.8% is your percent. So 27 is 20.8% or maybe 21% or something like that of 130. So again, if you just stick with this proportion, especially if you're in middle school, and yes, there are other ways to do this. There are other ways to solve this. There's the equation, there's everything. But especially when you're first learning percent, the proportion I have found, and this is a good note for teachers too, the proportion is really simple for students to kind of wrap their heads around first. Then there's some little shortcuts that you can do, right? Like I know that if I just divide the part divided by the whole, that's my percent. Times 100, that's my percent. Okay, but again, you just kind of have to let students kind of find their way towards that. You can show them, you can show the shortcuts, but start off by understanding that per 100 means that you're changing this relationship into being out of 100. Okay. All right, so let's see. Okay, so Pythagorean theorem. So straight. I'm gonna find C, but I got like 4 on A and 3 on B. Okay, so Pythagorean theorem is the question. So Pythagorean theorem is the question of the moment. All right, so Drake, tell me what grade are you in? Like, are you doing simplifying radicals, or are you just like rounding to the nearest tenth? Okay. All right, so Jesus on TikTok, I can help you on quadratics. And then let's see, Micah parallelogram. I'll get into that too. Let me do Pythagorean theorem first, okay? All right, so Pythagorean theorem. You always see that it's a squared plus b squared equals c squared, right? I like to move away from that a squared plus b squared equals c squared and just talk about, like, you've got the legs. So the legs of your right triangle are the ones that make up the right angle. And then the hypotenuse is always going to be the longest leg, or sorry, it's always going to be the longest side of the triangle. Okay, so you've got leg squared plus leg squared equals hypotenuse squared. Okay, so we're going to do, so that's what we're going to look at. So if I've got a triangle like this, okay, and I've got 3 and 4, and I'm trying to figure out this hypotenuse. Right. So my Pythagorean theorem, remember, is leg squared plus leg squared equals hypotenuse squared. So I'm going to plug those in. So 3 squared plus 4 squared equals h squared. Okay. So 3 squared is 9. 4 squared is 16. So what that means is 25 equals h squared. Now 25 is h squared. So to get h by itself, I'm going to take the square root of both sides. So the square root of 25 is the same thing as the square root of h squared. Now the square root of anything squared is just the thing. So the square root of h squared is just h. Square root of 25, you may already know this, but you may just need to use your calculator. The square root of 25 is 5. So my hypotenuse length is 5. Okay. So it doesn't matter what I've got here. Now, what does make a difference is, let me show you this one straight, because this one, this might show up too, but I'm glad that that made more sense. Okay. So if I had one of these where I had 8 and B and 10. Okay. So now, Abdullah, yeah, these are Pythagorean triples. Those are good to know. Okay, so now this one is a little bit different, right? Because now I don't know what one of the legs is, but I'm still going to plug in what I know. So I know that one leg is 8 squared. I know the other leg is b squared, and I know those added together are going to equal 10 squared. 8 squared is 64. B squared, I don't know what it is yet. And then 10 squared is 100. So I still want to get my b squared by itself so that I can take the square root of it. So I subtract 64 from both sides. So b squared is 36. I do the square root of b squared and the square root of 36. Square root of b squared is going to just be b. Square root of 36 is 6. So my leg for this one is 6. Okay, so it's still the same idea, right? You still plug it in all to the formula and all of that, but it's just a little bit of kind of manipulating in there, right? You're gonna have to just go through and kind of subtract and make sure you rearrange it as needed. Okay. All right, good. I'm glad that was helpful. Okay. So let me go back up. I know I told a couple of things. All right, bye, Strake. All right, let's see. Jesus needs help with quadratics. Okay, let's see. Didn't think I would ever say that. Okay. All right, so Jesus, I've got C equals, for that one. Got it. Okay. All right, so Jesus with your quadratics. What specifically with quadratics? Do you need help with factoring? Do you need help with solving, simplifying? What, give me a little bit more specific. Okay, and then Micah, so Jesus, once you give me the, feels weird talking to Jesus. Once you give me those details, we can jump back into it. But while I'm waiting, so Micah, so a parallelogram. Okay, so Micah is asking, find the values of the variables so that the figure is a parallelogram. Okay, so whenever this is the directions, right? When it's like find the value of the variables, so it's this. What I often tell my students is, okay, rephrase that as, if it's a parallelogram, solve for the variables. Okay, so there's a couple of different things with solving parallelograms, right? So a parallelogram is, we've got two sets of parallel and congruent sides. Okay, opposite parallel and congruent sides. Okay, now what that also means is that this angle and this angle are congruent. So opposite angles are congruent. Also, these opposite angles are congruent. These two angles are going to add up to 180. These are supplementary. So whatever you're given, right? If you have that, like, this angle is 45 degrees and this is, I don't know, 2x plus 5 degrees. Okay. Then what you would do is you would set it up. You would think, okay, well, 2x plus 5 equals 45, right? So 2x plus 5 is going to equal 45 degrees. So then you would subtract 5. You have 2x equals 40. Divide by 2, you get x equals 20. Okay. So it's just a question with any of these like diagram questions, you've got to figure out, okay, what do I know for sure? I know for sure that these two are going to be equal. Now, what I also know for sure is that if this angle were, I don't know, 10y plus 7, okay, then what I also know is that these two angles need to add up to 180, and these two angles add up to 180, right? So I can say 45 plus 10y plus 7 equals 180. So if I set up my equations, kind of translating it into an algebraic statement equation makes it a lot easier. So I've got 10y plus 52 equals 180. So then 10y, let's see, equals 128. Yes. And then divide by 10, so y equals 12.8. And there you go. Okay. All right, so Micah, hopefully that's helpful. If you have a more specific question, you can just pop it in the chat, okay? All right, so Jesus, back to your quadratics. You said solving. Do you need to be solving using a specific method? Or can you do factoring, completing the square, quadratic formula, anything like that? Okay. Let's see. Oh, okay. Over on YouTube, Ignited, you also did, you want a refresher on the quadratic formula. So we can do this. So let's do, you know what? Let's just jump into a quadratic, okay? All right, so what is a quadratic? Oh, Jacob, triangle similarity. I will put that on the list, okay? You'll be up next. Okay. Let's see. All right, so quadratics. All right, so let's say we have, so a quadratic equation or a quadratic function is when you've got something squared, right? A variable squared, okay? Now what this looks like on a graph is it's going to make a shape called a parabola. So it might look something like this. Okay. So it's a U shaped like this, a couple of different things. So this part here would still be the y-intercept, right? That's still going to be the y-intercept because that's what it is. Now, when we say solve a quadratic equation, what we mean is we're figuring out, oftentimes there are two solutions to a quadratic, okay? That's typically the most common. You'll see that it's two solutions, okay? And that's because what you're figuring out is where y equals 0. These are what we call the solutions or the roots of that quadratic equation. Okay, so this is what we are looking for. So this is why there's sometimes two solutions to a quadratic equation. Okay, and the reason there's two solutions is because if you think like x squared equals 64, so x squared equals 64, let's kind of talk about that really quick, right? X squared equals 64. Well, based on what we just did, right, we would do, okay, well, I take the square root of both sides. Square root of x equals the square root of 64. So x would be 8, right? So when you first learn square roots, that is correct, right? That's all you really need to do, right? But the problem comes up when you start dealing with integers and negatives, because it's not just positive 8. Yes, positive 8 squared does equal 64, but so does negative 8. Negative 8 squared is also going to be positive 64 because negative 8 times negative 8 is 64. So what we say is if x squared equals 64, then x can be plus or minus 8. It can be positive or negative 8. So that's where it comes from, those two solutions, right? If you think about, oh, there's a positive and a negative solution to that x squared piece, right? That is why we end up with these two solutions quite frequently, okay? So let's get into solving a quadratic. So I'm going to start with factoring, okay? So we've got, let's do, because somebody just brought up function notation. I'm just going to pop that in. So f of x, what that means is that's a function. Okay, so a function like a quadratic, okay, we've got a function of x equals, let's say, x squared plus 11x plus 24. Okay, so this is our function. F of x equals x squared plus 11x plus 24. Okay, so I'm seeing a lot of questions about derivatives and integrals and all of that. That's a little beyond what we do typically on these live streams, because we tend to stick kind of between algebra 2 and pre-algebra. But we have a really good community here, so there might be somebody that can get into the chat and answer you about those questions with derivatives and integrals, okay? Oh, good, Ignited. I'm glad that you were, okay, the plus and minus. All right, we got it. Okay. All right, so here we've got this quadratic in standard form. Okay, now with this f of x, this is function notation. So that means that this function, when I've got x as my input, is x squared plus 11x plus 24. Okay. Now, if I were looking at what is the function when my input is 2, so f of 2, that's what we say, okay, f of 2. Wherever that x appears, I'm going to change it to a 2. So this is going to be 2 squared plus 11 times 2 plus 24. So that's 4 plus 22 plus 24. So that is 26, and 24, that's going to be 50. Okay, so function notation is really just, this is your output, f of x is your output, or your y when you're graphing. Okay, so f of 2, the function when I put in a 2 is 50. The function when I put in an x is x squared plus 11x plus 24. Okay, so that's just kind of a quick little review of function notation. But in this case, what we're looking for is, whoops, just closed everything out. Sorry about that. Okay. Emily, you can always do math every day. Just because you stop teaching doesn't mean you have to not do it. Okay. So here, so I saw somebody asking about like, or kind of talking about what the vertex is. So when we're graphing quadratics, okay, one of the first things that we want to do is find the vertex. So I'm just going to kind of go through, you know what we're going to do is we've got this quadratic. I'm going to show how to graph it, and then I'm going to show how to solve it by factoring. Okay, that's what we're going to do. Okay. So when we're looking for the vertex, which is the curve, it's the lowest or the highest point. Okay, it's like the turn. That's what we call it. Okay, to find the vertex, so my vertex is going to be at something called my axis of symmetry. First thing I need to do is find negative b over 2a. Okay, now this negative b and this 2a, and even in the quadratic formula, it's yeah, Mateo, if you have specific questions, just pop them in the chat and I'll get into them, okay? So this refers to the coefficients here. So before the x squared is a, before the x is b, and the one without the it's the linear term, or not the linear term, that's the intercept, is c. Okay, so negative b, so this is going to be negative 11 over 2 times 1. Gross, this is ugly. Okay, so our vertex is going to be, our axis of symmetry would be negative 11 over 2. Ugh. It's not going to be very fun to graph this, guys. Gross. Okay. So then your vertex, so that would be your axis of symmetry. So then you would find this. I did not pick this one thinking I would graph it, but so now we've got to do, maybe I'll just show you guys how you would find the vertex. Blah. Squared plus 11 times negative 11 over 2 plus 24. Okay, so once I get that, then that's going to be where my vertex is. So it's negative 5.5 squared plus 11 times negative 5.5 plus 24. Negative 6.25. Okay. So we've got our vertex is going to be at negative 5.5, comma, negative 6.25. So I'm not actually going to graph this one, but that's where your vertex would be. Okay. Yeah, NumWorks. Oh my gosh. Okay, calculator questions. This is my NumWorks calculator, and I love it so much. It makes it so easy to simplify radicals, and y'all know that I love my NumWorks calculator. It just makes it so easy, especially on quadratics. On a quadratic equation, you can literally just type it in and graph it, and then you can find everything. On other calculators, you kind of have to remember like all these different keystrokes and things like that, that it's just kind of difficult to find it. So if you are interested in buying this calculator, which tends to be a little less expensive than other calculators on the market, go ahead and look on just go to the NumWorks website. I should also have some links in my profile, or we might be able to pop one into the chat. But it's a NumWorks calculator. Oh, it's so good. It's a really great calculator, and I wish that more people knew about it and use it, and I will sing its praises all day long because it's beautiful and it's pretty and it's easy. And what's also nice is that I'll show you guys on my phone that the app on the phone, it's kind of hard to see, but it looks exactly like your calculator. So you can also, if you want to try it out, you can just get this free app and you can just try the calculator right now on your app, on your phone or on your iPad or whatever. You can just go online. There's an emulator online. So it's the NumWorks calculator. There's not a model name or anything. It's just, this is the calculator. And they're working on some other fun things to do. I'm not sure how much I can say about it, but yeah, they're working on some other things that are like online and like their app and things like that. Yeah, there's only one model, but it is great. It's just much more intuitive for students to use, and it will simplify a radical for you immediately. Exactly. Yeah, it'll rationalize the denominator for you. Oh, it's so good. It's amazing. Okay. Like I said, I could talk about the NumWorks calculator all day long, but yeah, you can, if you're a teacher, you can get a free calculator from them. They will send you a calculator just like this one. But again, you can also just use the app on your phone and it looks exactly like the calculator. Okay. So let's solve this quadratic by factoring, and then I've got some questions about polynomials up there. I see a lot of people saying, please do polynomials. You gotta give me a little bit more information. Do you want to do like simplifying? Are you talking about factoring? What about polynomials do you want to go with, right? Okay, so factoring a quadratic right here. So one of the things that you do, so one of the first things that you do is when you're solving a quadratic, you make this equal to 0. Okay, because remember, we're looking for where it's crossing the x-axis, and where it crosses the x-axis, your y value is 0. Okay, so over here, x squared plus 11x plus 24. So what I'm looking for is I can't really solve this as it is because I need to make sure that I can solve it and put it in a way that I know for sure something to do, right? I could plug in and guess and check with this, but I don't have that kind of time, right? So what we're going to do is we're going to use something called factoring in the zero product theorem zero product property, to rewrite this in a way that I can solve and find those two values for sure. Okay, so I'm going to look at 24. And what I'm looking for is I'm going to look at what multiplies to 24 and adds to 11. So I've got 1 and 24, 2 and 12, 3 and 8, 4 and 6. I like to just list all of my factors out and then go back and see, okay, which ones are which ones are going to add to 11. Okay, and I see 3 and 8. So 3 and 8 add to 11 and they multiply to 24. So I'm going to rewrite this quadratic here using my 3 and my 8. So it's x plus 3 times x plus 8. Now here I've got two statements that are being multiplied together. I've got two things that are being multiplied together to equal 0. Now in order for these two things to multiply together to equal 0, one of them has to equal 0, right? So if one of these is equal to 0, then the whole thing is 0, right? So that's where I get my two roots. So either if x plus 3 is the one that equals 0, this whole thing is going to equal 0. But if x plus 8 is the one that equals to 0, the whole thing is going to be 0 also. So if x is negative 3, or if x is negative 8, that's going to equal 0. Okay. Multiplying two trinomials and then simplifying. Yep. Okay. Oh, Landon, what grade do I teach? So primarily I teach 10th grade and 11th grade. I stick kind of in that algebra 1, geometry, algebra 2 realm primarily, but there are some pre-calc concepts in our 11th grade curriculum. So if I did negative 3 squared, that's 9, plus 11 times negative 3, which is negative 33, that's going to be negative 24, plus 24 is 0. Check. Negative 8 squared is 64, minus 88, which is negative 24, plus 24 is 0. Check. So my two solutions, my two spots where I'm going to, my two spots where it's going to cross the x-axis is at negative 3 and negative 8, and those are my solutions. Oh, secret. Without fully factoring, how can you tell how many real solutions this quadratic has? Okay, so you can use what's called the discriminant, right? Which is in the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I've been teaching for 20 years and I still have to sing this to myself. I don't know. So the discriminant is right here. So b squared minus 4ac. Okay. This will tell you how many solutions it has. Okay. If b squared minus 4ac is negative, you have no real solutions. They would be imaginary. If b squared minus 4ac is a rational number, you are going to have real integer solutions, I guess I should say. Okay, so that's what you can use to determine, yeah, the b squared minus 4ac, that's that stuff. Okay. Oh, no worries. Thank you for policing the chat a little bit, guys. Sometimes I get so distracted by math that I miss some, if we have some turds in the punch bowl. Okay. Let's see. Okay, so Mateo, multiplying two trinomials and then simplifying. Okay. Perfect. Do snowflake method. I don't know if I know what the snowflake method is. Lindsay, yeah, you can give me a problem. And we'll see if I can solve it. Snowflake method, is that for factoring? Method quadratics. I'm assuming it's quadratics. We do need women in STEM. We're getting there. Oh, there's, so one of my, I love factoring. I love factoring because there's so many different ways to go about it, right? Like you can do the slide and divide. You can do this snowflake method, right? Ooh, AX, AC, B. Okay, I'm gonna have to learn what the snowflake method is because I don't know if I've ever really worked with that. Interesting. Ooh, all right. You gave me something new to look at. Okay, snowflake method. I'm gonna have to look that up. Or I'm gonna have to dive into a little bit more. Okay, so multiplying two trinomials. Okay, so anytime we're multiplying polynomials together, a polynomial is like a quadratic is a polynomial, binomial, monomial. These are all terms. So these are things that are separated by adding and subtracting. And yeah, so adding and subtracting, there's all these different terms that are in there. Okay, so if I'm multiplying, like let's start off really easy, right? 2x plus 4 times x squared plus 3x minus 2. Okay, so if I'm multiplying these two together, so what you want to do is you want to make sure that everybody in each of these monomials or each of these polynomials gets multiplied by the other term. So 2x needs to be multiplied by all of these. 4 needs to be multiplied by all three of these. So you can go through and you can organize it very clearly like this. Okay? Oh, hi, Amber. Good to see you too. Doing well. We just switched to Sundays for a while. It got too hard on Thursdays. So, all right. So I can go through and I can kind of think of this as distribution, right? So I can think of that as distribution. So where I would have 2x times x squared plus 3x minus 2 plus 4 times x squared plus 3x minus 2. Okay, so I can kind of split it up like that. Okay. Or what I can also do is what I can also do, and what sometimes is a bit easier, especially when you're first learning this, is to make a box. I like using the box method for multiplying these together because it keeps things a little bit organized. And especially for students when they're first learning how to do this. Sorry, I had to do my little puzzle piece. When they're first learning how to do this, it's a little bit easier because it goes ahead and it kind of pairs everything up in a nice way too. So, but let's kind of follow this along. So I would have 2x cubed plus 6x squared minus 4x, and then plus 4x squared plus 12x minus 8. So again, this method works just fine. Okay. Lindsay, okay, Lindsay 9 square root. Okay, Lindsay, I'm going to have to take a look at yours a little bit more once I get through this, okay? All right. So it becomes 2x cubed because you've got 2x times x squared, and the exponent rules, when you're multiplying those together, you add the exponents together. Okay, so now you would have to kind of hunt through and find the like terms, okay? But let's compare this to the box method. Okay, so the box method, I've got 2 terms here, and I've got 3 terms here. So I'm going to make a 2 by 3 box. Okay, if you've done biology, you'll kind of think about, it's sort of like a Punnett square. Okay. So over on this side, I've got my 2. I'm going to do my 2x and a plus 4. Okay. And then over here, I'm going to put my 3 terms. I've got x squared plus 3x minus 2. So again, this is going to keep everything organized and tidy. So now it's just like a times table. I'm going to multiply them together. So x squared times 2x gives me 2x cubed. 3x times 2x, 6x squared. Negative 2 times 2x is negative 4x. Now I go down and do this row. It doesn't matter which one I do. It doesn't matter. X squared plus 4 gives me 4x squared. 3x times 4 gives me 12x. If you notice, I kind of stopped writing the plus or minus because in here, if there's no sign, I just know that it's positive. So here I've got negative 2 times 4, which is going to give me a negative 8. Now here is the really beautiful part about this box method, okay? I don't think the beauty of math is emphasized enough, right? Like, there are things that just kind of work out that are like, oh, that's really cool. So one of the beautiful things here is that here we've got 2x cubed. If you notice, the like terms just kind of line themselves up, and it's a beautiful thing. So 2x cubed, this is my only value that's to the third. Okay, so 2x cubed. Look at these two right here. So right here, I've got 6x squared and 4x squared. They're lined up. It's beautiful. Plus 10x squared. Negative 4x plus 12x is plus 8x. And then this minus 8, that's the only constant here, so it's minus 8. So I didn't have to go through and hunt and find each of the like terms, and I might miss a term. It lines up diagonally, and it's so nice and easy. So I prefer using this method when I've got like trinomial by trinomial or binomial by trinomial, right? All of that. Okay. Now standard form is going to be where you have all of your variables are in descending order of their powers, of their degrees. Okay. So this is to the third, this is to the second, this is to the 1, this is technically to the 0, right? But that is in standard form and in order. Okay. So FOIL method, using that acronym FOIL really only works for if you have two binomials. Okay, and it's just so you keep track of who's being multiplied by whom. Okay, so FOIL specifically doesn't really work with this one because I have 3 terms in this one. So FOIL will only work if you have 2 times 2, right? So you have A plus B times C plus D. That's it. Okay. Okay. Let's see. Thank you, Lindsay. Oh, thank you. Okay, somebody asked, Lindsay, while I write out your problem, so somebody asked about, do I think that some math is useless? So I don't think there's any math that is useless. However, there is some math that is more useful than others. But I think it's important for us to always keep in mind that there's now I'm starting to think about things that you don't really have to do, like rationalizing the denominator. You don't really have to do it, but I wouldn't say it's useless though, because you do use it. Okay. So Maddie, so you say you FOIL all the time, but you're not really, because foiling is first, outside, inside, last. So you can't do that with anything that's not a binomial by a binomial. Okay, let's see. Lindsay, yours keeps blocking. Okay, 9 square root 2x plus 17 plus 9 root x plus 9 root x plus 12 root x plus 33 equals 180. Is this right? Whew! This is quite a problem. Okay, is this right? It is really long. This is going to be like a half pager. Okay. I'm going to go ahead and I'm going to start with, just going to subtract the 33. So now I've got 9 root 2x plus 17 plus 9 root x. Oh, actually, you know what? I'm going to do two things in one step. So 9 root x plus 12 root x. Because root x and root x, those are basically like terms, right? So this is actually going to be plus 21 root x equals, I'm going to do 180 minus 33, so that's 147. Okay. All right. So now let's see, what have we got here? 2x plus 17. I'm tempted to square these, but I don't want to. Okay, so I can, let's see, 3, 9. Let's simplify some of these numbers. So I can divide everything by 3. So now I've got 3 root 2x plus 17 plus 7 root x equals 147. Okay, so here's what I'm going to do. Yeah, here's what I'm going to do. I'm going to, ooh, I'm writing really small, sorry. So what I want to do is I want to get a root by itself on one side of the equation. So I'm going to go ahead and I'm going to get this one all by itself. So 3 root 2x plus 17 equals 147 minus 7 root x. Okay. I guess I could divide by 3 too. It doesn't really matter. But now, since this is basically like a root, divide both the 148. Oh my gosh, you're right. It isn't 147 anymore. Thank you. Good catch. Okay. So because I divided it by 3, so that should be 49, right? So that's 49. 49 minus 7 root x. I feel like feels like there's something there, huh? Okay. So now let's see. Thank you. Good catch. Whoever got that. I guess the right answer with a different method. Why is it wrong? If someone gets the right answer with a different method, why is it wrong? It depends on what the question was. If the question is to get you to use a specific method, then that's what they're asking you to do, is to show that you understand that method. But if it's up to you to pick your method, shouldn't be wrong. Okay. Okay, so I'm going to divide everything by 3. So that's going to give me root 2x plus 17 equals 49 minus 7 root x over 3. I'm going to need another board for this. Oh my gosh, Lindsay. What a way to end the night. Just kidding. This is fun. Yeah, of course. I'll leave it up. Okay. So now that I have this root by itself, I'm going to square everything. So I'm going to square both sides because I want to get rid of that radical. So root 2x plus 17 squared is just going to be 2x plus 17. Okay. Equals, let's see. So it's going to be 49 minus 7 root x squared over 9. Okay, because we multiply and multiply. All right, so might be an easier way to do this, but okay, so 2x plus 17 equals 2401 minus 14 root x plus, that would be 49x. All over 9. Well, it would be 49 minus 7 root x times 49, whoops, minus 7 root x. So that's going to be the 2401. Oh, wait. That's not going to be minus 14. These are big numbers. Minus 686 root x plus 49x. Yeah. 686, so that's 12. That's not going to divide by 9. Okay. So now I want to get that root x by itself again. How did you get 49x? Oh, yeah, because it's the negative, or it's the 7 root x times 7 root x. That's going to be 49x. Okay. So I'm going to multiply both sides by 9. So that gives me 18x plus 17 times 9, which is 153, is 2401 minus 686 root x plus 49x. Oh, we got 18 minus 49, which is negative 31x. 153 minus 2401 minus 2248, negative 686 root x. Mateo, I'm assuming you're joking, but this isn't a geometry class? I do this with like honors algebra 2 is even, I think, stretching it a little bit. Okay, so I'm going to divide everything by negative 686. So I've got negative 31x minus 2248 over negative 686 equals the square root of x. Oh my God. And then I'm going to square that. Yeah, I mean, I guess it is adding up to 180. This is awful. This is awful. Oh my God. Yeah, the summing to 180 is what's telling me that it's probably angle measures, but still. Well, okay. So then you would square both sides. So this feels like, am I okay? No, I'm not okay with this problem. This is not fun. Because, well, just because, and like, you would just have to keep going. So then you're going to square this again. So you're going to be squaring these again. So now you're looking at negative 31x squared. And then you're doing all of that because there's not even any, I can't even reduce this at all. So I'm thinking that if it's for geometry, that just feels like complete overkill for that. Yeah, you're going to have to use MP. I'm kind of feeling the same way. Yeah, I almost feel like maybe this is not what she meant to set you up with. Because just putting in these putting in these radicals that are not, like, this is fine, right? Like, because then you just combine those. But then having that in there also just feels cruel, and it feels like I'm missing something. But so then you would just square this, and then you're going to keep going down that road until you have to do until you have to do quadratic formula. All right, let's keep going. I don't know how you're going to get a screenshot of all of this, but okay, so then you square it. So this becomes, oh my God. So this becomes 961 x squared This is absolutely insane. 139,376x plus 5053504. This is not, I don't think this is divided by negative 686 equals x. This is crazy. This is crazy. This is crazy. Because then if you're subtracting, like, this is absolutely, like, I would like, honestly, I take screenshots and be like, you broke this math teacher's brain. Because it's just like, is it solvable? Sure. But yeah, you do square 60. Oops, I missed that one. Okay, so it's over 470,596. Like, this is one of those problems where you go, what is the point? The answer is 16. Okay, so all right, so this is the original problem, right? So we've got 9 root 2x plus 17 plus 9 root x plus 12 root x plus 33 equals 180. So you could potentially square both sides when you have 9 root 2x plus 17 plus 21x, 21 root x, sorry, equals 147, right? Yeah. You could do that, and then you could square both sides, but then you're still dealing. That might be how to go about it. Is if we square both sides. Oh my god, it is going way over time. The answer is 60. Okay, now this is bugging me. Okay, so let's go from here. So let's try this tactic, okay? So let's try squaring both sides, squaring everything. Okay, so we've got 9 root 2x plus 17 plus 21 root x times 9 root 2x plus 17 plus 21 root x. Remember, guys, if you see an error, please let me know. Equals 21,609. Okay. So this times this is going to be, so now we can FOIL it. Oh, we could have divided it all by 3, yeah. It's okay, we can simplify it later. Well, actually, we can do that, yeah. We can do 3, 7, 3, 7, 3, 7, 3, 7. And then we've got 2401. Okay, because we did do that before, so 2401. Okay, so these two multiplied together are going to be 9 times 2x plus 17. Oh, this is going to get so... I mean, at least it gets them all under 1. Okay. So it's going to be plus... You can use it for do like 1/2 powers. Vacuum, don't really get into AP Calc. Because this is going to be, let's see, that's 21, 21. So that's going to be 42 root x 2x plus 17 plus 49x. So you're not really, it's not really making a huge difference. It doesn't feel like. Lindsay, I'm giving up. I'm giving up. Yeah, I'm Oh, okay. So somebody over on YouTube said, I looked it up and this has no solution. Okay. All right, I'm a roast it like it's 6. There you go. Okay. The final answer did not equal 180, but it equaled 16. Oh, so maybe that was supposed to be equal 16? Oh. I don't know. I don't know how you get 16. I don't know how you get 16 for this, unless you just keep going. But this is so... Unless you're just doing guess and check, unless you're just plugging it in. like I can see how 16 would work, because if you plug it in back up here, right? If we were to just plug in 16 for x, like really and truly, it might have been that so this is the original question up here, guys. It's kind of hard to see. So if we do, yeah, we can divide everything by 3. So if you know for sure that it's a perfect square, that the x is, factor out a 3. I mean, I can just divide both sides by 3. What are the 3 components, Lindsay? The 9, 9, and 12 with the square roots. Okay, so then where did this plus 33 come from? So it is 12 root x plus 33 is like one of the angles. Yeah, I think it's just going to be a guess and check. I think it's going to have to be a guess and check problem, because to actually solve this, I mean, you saw, like you saw how crazy it gets so quickly. Yeah, have your teacher email me. Have your teacher work it out, and I mean, please send me a message if you are able to get a screenshot or something of how she actually solved it. Because the only way that I can see is to just guess and check, and that would be like, well, so here's the thing, is that you can't just square the whole thing, because these are different terms. So what we started out doing was to try to isolate the root on one side, and then you can square it, but then that quickly escalated because you're going to have to square it a couple of times. Yeah, Miss Frank, go for it. If you can think of something else that I wasn't trying. Okay, but guys, I'm gonna have to call it a night. So Blunderfisher, that is what we did. Yes, Lindsay. I'm on Instagram and YouTube, so send me a message. Okay. All right, we've got somebody else that says yes. Yeah, send me a message. If you guys get it, send me a message, and I'm gonna keep working on this too. All right, but Lindsay, I'm actually really happy that you sent me this, because this was fun. All right, guys, have a great night. Good luck this week. Yeah, Miss Frank, please send it to me, and Lindsay, send me what your teacher says, and maybe I'll make a little follow-up video once we figure it out. Okay. All right, guys, have a great night. If you have any questions or anything like that, let me know, and you can send me a message. All right, Lindsay 0517. Is it 2 Ys or 1 Y or 3 Ys? Okay, so it's 2. Okay. All right, awesome. All right, bye guys.